Now that we've looked at the idea of what polar coordinates are, let's start thinking about, start creating some polar graphs. So let's start off with a very simplistic graph where r of theta simply equals theta. Okay, so I'm going to draw some axes here to work with. That should work. Actually, I need to go maybe a little bit farther. That should be good enough. Okay, so when theta is 0, r of theta is also 0, which means I'm at the point 0, 0. When theta is pi over 6, the radius is also pi over 6, which is approximately 0.5236. So at pi over 6, which is roughly this angle here, I'm at a distance of a little bit more than a half. So I should be roughly at that point right there. When theta is pi over 4, the radius is also pi over 4, so that's about 0.7854. So at pi over 4, I'm at just shy of 1, which is like roughly in here. At pi over 3, the radius will be 1.0472. So at a third of a pi, I'm just a little bit bigger than 1. At pi over 2, pi over 2 is 1.57-ish. I'm going to be roughly here. I can see this graph starting to develop. It's coming around like this. At 2 pi over 3, well, 2 pi over 3 is going to be 2.0944. So let's see, at another third of a pi, roughly over here, I'm a little bit bigger than 2, so I'm roughly here. Obviously, this is not very well to scale. At 3 pi over 4, it's approximately 2.3562. So that's going to be a little bit more than this. So my graph is looking something like that. At 5 pi over 6, it's going to be approximately 2.6180. So 5 pi over 6, it's going to be bigger, a little bit more than 2.5, so roughly here. And pi obviously is going to be about 3.14. So at pi, a little bit bigger than 3. And then I'm going to jump all the way down to 3 pi over 2, and actually 2 pi, because 2 pi is a little bit bigger than 6. So I know this is going to come around like this and like that. The exact value here, grab a calculator and figure it out. But between 0 to 2 pi, I get this circular spiral sort of a thing. Okay, so what if I now consider r of theta equals sine theta between 0 and pi? Well, sine of 0 is obviously 0. Sine of pi over 6 is a half. Sine of pi over 4 is root 2 over 2, which is approximately 0.7071. Sine of pi over 3 is root 3 over 2, which is approximately 0.8660. Of course, sine of pi over 2 is 1. Sine of 2 pi over 3 is root 3 over 2, which again is about 0.8660. 3 pi over 4, sine of 3 pi over 4 is going to be root 2 over 2, which is again approximately 0.7071. Sine of 5 pi over 6 is a half, and sine of pi is 0. So if I draw my axes, at 0, I'm at 0. See, at pi over 6, this is roughly pi over 6, pi over 4, pi over 3. So at pi over 6 if this is 1, I'm at a half, so I'm roughly here. And then I'm at roughly 0.7. And then I'm at roughly 0.8. Then I'm at 1. And then I'm back at roughly 0.8. See, here, here, and here roughly. So I'm roughly back at 0.8. Then at roughly 0.7. Again at a half, and back at 0. So what do we get? We got a circle. So for r of theta equals sine theta, I'm going to get a circle for theta between 0 and pi. Now if I go to 0 to 2 pi, all that's going to happen is I'll go around once, and then once I'm done, I'll simply go around again, and again, and again. If I keep adding pi's to it, 2 pi, 3 pi, 4 pi, every pi, I'll simply go around and circle once. Okay, in general, r equals a sine theta. All these guys are circles. And the radius is a over 2, and it's centered at 0, a over 2. Well, the one we just did, in this case, a equals 1. So the center should be, in terms of x and y, should be at 0 and a half, which it is, because this was 1 up here. So in the center, that's a half. So polar functions of the form r equals a sine theta are again circles. The radius is a over 2, and that's going to be the center of the circle.